Okay, hi everyone. I just wanted to make sure that we had an example of just a straightforward trigonometric equation that you had access to here. Notice that we're in degrees, okay? So that makes things a little bit easier. So to start off with, and I take a look at this, I notice that it's a cosecant. Well, I don't want to work with cosecant, okay? I'm far too lazy to do that, so I'm just going to get clever here and I'm going to say, well, I know that cosecant is 1 over sine. Okay, so I'm going to just replace cosecant with 1 over sine. Now notice at this point I haven't done anything because 1 over sine is cosecant. Okay, so I haven't done anything here. But at this point here I've got the sine in the denominator and I don't like that either. So what I'm going to do here is I am going to change now what's going on here, but I'm going to do it to both sides of the equation, so that's okay. I'm going to reciprocate the left-hand side and I'm going to reciprocate the right-hand side. Now remember, dividing by a negative or dividing a negative by a positive, the result is the same, so it doesn't really matter where that negative goes. So now I've changed the original question to one that I'm much more happy with. Sine of theta is equal to negative 1 over 2.46. Okay, so now I'm going to ask myself, okay, by looking at this, I see that it's negative. I'm going to ask myself, okay, where does the sine ratio become negative? And I know that that is going to be in quadrants 3 and 4. Okay, and then I'm going to go to my calculator and I'm going to figure out the reference angle. And I'm going to do that by doing the inverse sine of 1 over 2.46. Now remember, I'm not going to include the negative there. The negative told me what quadrants it's in, that's fine. Now what I want to do is figure out the value or the magnitude of the angle that I'm going to be putting in those quadrants, the reference angle. And I don't want the negative there. Okay, and when I do this, I'm going to get, rounded to the nearest degree, 24 degrees. Okay, so now in the third quadrant, I'm going to take 180 degrees plus 24 degrees, and that is going to get me 204 degrees. And then I'm going to go into the fourth quadrant, and I'm going to do 360 degrees minus 24 degrees is equal to 336 degrees. And I'd be very happy with that, except that the domain is slightly different. Okay, and you need to make sure that you're aware of this. So anyway, I kind of move forward with that the way a lot of us do it. But remember what this is saying, the domain is saying. I already know that this has got two solutions, one here and one here. Okay? But the domain gives me a negative half rotation this way. That's the negative 180 degrees. And then the 360, the full 360 degrees there. Now, the two angles that I've just dealt with are coming from this full positive rotation. Okay, so those are good answers here, but what I'm missing are the two angles that come from the negative half rotation. So I got to bear in mind that this is 24 degrees and this is 24 degrees. And I got to think, okay, what angles would those be? Now I'm still looking at third and fourth quadrant angles. Okay, so I'm still looking for the third quadrant, I'm still looking for the fourth quadrant, but there's two more here. This fourth quadrant angle, if I take a look at the negative rotation, that is going to correspond to negative 24 degrees. Okay, and then if I take a look in the third quadrant, okay, I'm rotating back. Remember, this is negative 180 degrees, but I'm coming back. I'm really rotating positively backwards there, 24 degrees, and that is going to get me 156. Or sorry, negative. Here I am missing that. Negative 156 degrees. So my four angles are going to be 204, 336, negative 156, and negative 24. Okay, in the quadrants 3 and 4, and in the domain that is specified by the problem.